Hello and welcome to your lecture on molar conversion. For this lecture, you are going to need your red, white, and blue periodic table. You are going to need your calculator, and you're going to need a pencil or pen and paper. As we go through this lecture, feel free to pause at any point or even rewind this video to clarify any questions you have or to get a better grasp on a situation, practice things. I will, of course, as we go through this, give you stopping points where you may want to pause the video and do it yourself and then check and see if you have the correct answer. But again, you're welcome to do so anywhere in the video. Hopefully, any questions you have or clarification you need will be taken care of in the video. However, if not, I strongly recommend that you go to your instructor and address that with your instructor before we go on to the next segment or the last segment of these videos. All right, so let's get started. What you see in front of you is the makings of a mole map. Before we get into the actual design of the mole map, you should have already received instructions on how to make your mole and what goes on the belly of your mole. This is the first part that goes on the belly of your mole. When you're making your mole, make sure that you're able to very clearly read the mole map as well, of course, of the stoichiometry formula that you're going to be using. But make sure that you can read the mole map because it will easily guide you through these problems. If you do not have a mole or you don't plan to make a mole, then you're going to need to know this mole map by heart. So once we finish putting it together, I would recommend that you pause the video and write this down and start memorizing it now. As we looked at this map, the center of this map is central to everything that has to do with the mole map, and that is the mole. Everything begins and ends and goes through the mole. If the mole is not there, if you don't know how to find what the mole is or what the molar mass is or any of those things, you're going to have difficulty. So make sure you've reviewed what molar mass is using your red, white, and blue periodic table. We've talked about the mole as it pertains to Avogadro's number. Make sure you go back so you understand that Avogadro's number for a mole is 6.02 E23. The only thing really new on here is, of course, the volume of gases, and we'll talk about that shortly in a minute, and it fits in with the rest of the mole map. So let's look at how the mole map occurs and how it works. The mole is your central. So to get to volume of gases, to get to mass, to get to particles, again, everything has to go through the mole. If I know the moles or the number of moles of molecule, then I can easily figure out what the mass of the molecule is by multiplying the mole times the molar mass. Well, where's the molar mass at? The molar mass is on your red, white, and blue periodic table. To get to the volume of a gas, if I have moles of a substance, I can multiply it by 22.4, which is the volume of a gas at standard temperature and pressure. And to get to particles of a substance, if I know the moles of a substance, I can multiply that by Avogadro's number of 6.02 times 10 to the 23, or e to the 23, which is how I'll probably be saying it through this. But notice that everything is mole 2, and mole 2. And also notice that I keep saying when I'm talking about moles, you have to multiply, multiply, multiply. So I want you to get into your head the word mole is for multiply. Let me write that down. Mole means you have to multiply. Isn't that cute? But believe it or not, it is going to help you as you go through this unit in answering these mathematical problems. Mole is always multiply. If you're not going from mole to anything, then you don't multiply, you divide. So let's see what I'm talking about. Well, let's go back to, I know how to get from moles to mass. I have to multiply by the molar mass, which is on your red, white, and blue periodic table. To get from mass back to mole, well, I just have to do the opposite. I now have to divide by the molar mass. To get from moles to a volume of gas, I have to multiply by 22.4 liters. To get from the volume of gas back to the mole, I'd have to do the opposite, which is divide by 22.4 liters. And to get from moles to particles, I have to multiply by Avogadro's number of 6.02 e to the 23. To get from particles back to mole, I have to divide by Avogadro's number of 6.02 e to the 23. So all of the things that we have can easily be acquired by either multiplying from the moles to or dividing back to the moles from. Our mass, of course, is in grams. Our volume is in liters. And our particles means we're talking about atoms. We're talking about ions. We're talking about molecules. We're talking about pieces. Okay? So, the unit for the volume is liters, the unit for the mass is grams, and the unit for particles, well, that depends on what you're talking about, atoms, ions, molecules, or pieces. This is the mole map that you need to either memorize or make sure that you have on the belly of your mole. Okay? One hint, caution, those of you who are making moles, make sure that only the things that are given to you as approved to be on the belly of your mole are on the belly of your mole, because they will be checked. And if your mole has any other information than what we've given you, you're not going to be able to use that mole on the test. If your mole has just that information, it is always welcome to the table. It's welcome for any test you have. It's welcome for the quarter exam. You can make the mole as big as you want or as small as you want. So that's just a caution. Make sure that you only have those things that are approved on the belly of your mole, and make sure that you can read it clearly. For those of you who are memorizing this, my recommendation is that you get this whole thing memorized, and before you take any test, before you even do the test, on the back of the test, write out the mole map so you won't have to try and keep that in your head while you're doing more complex problems. Okay? All right. So here is the example of another mole map. It's just a little bit more colorful, but it still has the same. You can still see that mole is in the center. You have to go from moles to volume of gas, moles to representative particles, moles to the mass. And you always multiply when you do that. And if you're going from particles back to moles, or mass to moles, or volume to moles, then you're going to divide by whatever number it is that they've given you. The only number that fluctuates is the molar mass. And that fluctuates because that all depends on what the compound is. The rest of these numbers stay the same. Avogadro's number doesn't change, and the STP volume number doesn't change, okay? One last thing I want to point out to you on this mole map. Please note that you can never go from mass to particles. You can never go from mass to volume. You can never go from volume to particles. It has to go through the mole. Everything has to go to the mole. So if I want to go from volume to particles, I have to go from volume to moles, moles to particles. If I want to go from particles to mass, I have to go from particles to moles, moles to the mass. If I want to go from mass to volume, I have to go from mass to moles, and moles to volume, and vice versa. You can never just skip moles and go across. Mole is your pivot point. Okay? All right, so let's get started. I'm going to go kind of slow because we're going to walk our way through. Make sure you have your calculator. Make sure you have paper. And I will walk you through it, okay? All right, so let's look at the first one. Given 21 grams of water, find the moles. Now, before I do this, please make sure that you have written down the mole map, whichever one you want to use, on a sheet of paper. If not, go back, pause this video, and make sure you get this written down before you go forward. You're not expected to know it now because I'm just introducing it to you, but practice is going to get that ingrained in you. So make sure you have that written down before we start doing these problems. Okay? Either one is fine. So, given 21 grams of water, we need to find the moles. Well, we have, if our moles is in the center of your mole map, you want to go from moles to grams and grams to moles. So your mass is here. Okay? So we know that the constant that we use, of course, is molar mass, which is grams to mole. So what do? I'm going from grams to moles. So if I'm going from mass to moles, I'm going to need to divide this by the molar mass, because we said you multiply to go from moles to anything. Well, I'm going from mass back to moles, so I need to divide, and I need to divide the molar mass. Okay? So, when we do the problem then, we take the 21 grams of water and we divide it by the molar mass of water, which is 18 in grams. So clear your calculator, and on your calculator we're going to put 21 divided by 18 and push your equal sign. When we do that, you are going to, see if I can get this to work. There we go. 21 divided by 18, which removes your grams. That is going to give you 1.17 moles of H2O. Please note, in this answer, not only do I have the number, but more importantly, I have the units of what I'm talking about. We are very big on units. If you give me a number and there are no units, it is going to be considered incorrect. Okay? We're also very big on making sure you do accuracy. If you know how to round, that's great. I can take 1.2 moles of H2O if I've asked you to give it to me to the nearest tenth. I can take 1.17 moles of H2O if I ask you to give me the answer to the nearest hundredth. And I can take 1 mole of H2O if I've asked you to give it to me to the nearest whole number. You have to be able to round correctly. You have to be able to give it to me in whatever format it is that we're asking you to. Okay? But most importantly, with all those numbers, you had best give me the unit and who it belongs to. So write a note to yourself, highlight it, take a picture, whatever it is you need to do. Okay, let's do another one. This time I have 1.2 moles of water and I need to find the grams. So once again, I have moles and I have mass. And I know I'm dealing with grams per mole. But this time I'm going from moles to grams, so I need to multiply. Okay? I'm going to use the molar mass, but I'm going to multiply. So I'm going to take the 1.2 and multiply it by the molar mass of water. So let's see what happens. 1.2 times 18. So clear your calculator. Open your you don't even really need parentheses, but 1.2 times 18. Press the equal sign. Your moles, of course, are going to be canceled because you're multiplying it by the molar mass. And your 1.2 times 18 is going to give you 21.6 grams of water. So I have my number, 21.6, and grams of H2O. Again, make sure you're very careful with your masses and with your units, whether you're talking liters or grams or particles, pieces, whatever. Make sure you give me those units, okay? If I asked you to round this to the nearest whole number, it would be 22 grams of H2O. All right? Okay. Let's do another one. And again, feel free to pause these. Go back, write your answers as necessary. Given 26 liters of water, find the moles. So here we have moles, and we have volume, which is in liters. Our unit is 22.4. Okay. I am going from liters to moles, so I'm not going to multiply. I am going to divide the 26 by the 22.4. So here's your setup, 26 liters times 1 mole per 22.4. The liters are going to cancel out. You are going to have 26 divided 22.4. So clear your calculator, put 26 divided by 22.4, press the equal sign, and you should get 1.16 moles of H2O, my number, my units of H2O. This answer is to the nearest 100th. If I wanted the nearest 10th, it would be 1.2 moles of H2O. Dr. Hudson, why did you take the ES off of moles? Believe it or not, MOL is the abbreviation of moles. If I wanted it to the nearest whole number, it would be 1 mole of H2O. Okay? All right. Let's go on. Let's do another one. Given 1.2 moles of water, find the liters. We have moles, and this is volume, and that is 22.4 liters. I'm going from moles to liters, so I'm going to multiply, right? Okay, so let's look at the setup. 1.2 moles times 22.4. Having a little bit of delay in my technology. There we go. So clear your calculator. 1.2 times 22.4. Press the equal sign, and you should get 26, excuse me. I rounded it in my head. 26.9 liters of H2O. There's my number. There's my unit. Do I have to write liters? No, you can use it with a capital L. You could also write it if it makes you feel better. Liters of H2O. This is to the nearest 10th. If I wanted it to the nearest whole number, it would be 27 liters of H2O. Okay? Okay. Let's do another one. This time I have 1.2 moles of water. Find the number of particles. Remember that particles are pieces or atoms or ions. That is Avogadro's number. So we're going to take this one really slow because we need to make sure we have all our keys and such. So I have mole, and we're talking about particles. In this case, our particles have to do with Avogadro's number, which is 6.02 e to the 23. If you're going to use the times 10, it has to be 6.02 times 10 to the 23. And to do that, we need to pause for a minute and talk about the caret key. The caret key is a key on your calculator which allows you to put things to a power, to an exponent. So if you're going to use the 6.02 times 10 instead of the 6.02e, then you need to know where the caret key is, because that tells you you're taking 10 to that power. Okay? But if you do that, please note that this has to be in parentheses each time, because the parentheses will tell your calculator that it's one thing. Otherwise, just use 6.02e to the 23, because that e is actually equal to times 10 and the caret key. And your calculator knows that it also is in parentheses. That e key does it all. But if you're not going to use that, please make sure that you take 6.02 times 10, caret key 23, and that's all in parentheses. Okay? So back to the problem. We are going from moles to particles, so we're going to multiply. All right? So we're going to take 1.2 moles, and we're going to multiply that by Avogadro's number. So let's set it up, and then we'll put it in your calculator. Okay? We're going to multiply. So what I want you to do, and depends on what calculator you have, you're either going to clear your calculator. If you are going to use the E key, you're going to put 1.2 times 6.02 e to 3 equals. If you're not going to use the E key, you're going to clear your calculator and put 1.2 times, open parentheses, 6.02 times 10, caret key, 23, close parentheses, equals. Either one is fine. Just, again, remember that if you do it this way, you have to have parentheses. Okay? All right, so let's see how they do it here. When you pressed your equal sign, you should have got 7.2. And on your calculator, if you go across, you should see a little times 10. And then keep going to the right. You got to go all the way to the right, read everything on the screen, and you should see 23. Whether you use the E key or not, that's what your screen should look like. So here we have your number. Let me do it this way. And here you have your units of whatever it is that we're talking about. Okay? This is to the nearest tenth in scientific notation. If I wanted it to the nearest whole number, it would be 7 times 10, 23 particles of H2O. Or I could put 7 E 23 particles H2O. That's if I wanted it to the nearest whole number. If I have it to the nearest tenth, I can have 7.2 E 23 particles H2O. See the different ways it's represented to the nearest tenth and how it's represented to the nearest whole number. All right? Now, let's do one more example. Given 7.34 times 10 to the 45 molecules of H2O, find the number of moles. So this time, I put my moles here and put my particles here. Well, it says molecules, but remember particles are atoms, ions, molecules, pieces. Okay, so since I'm going to the moles, I'm not going to multiply. I'm going to divide by, and that is going to be the 6.02 E23, or Avogadro's number. All right, so you ready? Okay, let's have them set it up for us. 7.34 times 10 to the 45 over 6.02 times 10 to the 23. Again, notice they have it set up for you if you're going to use it with the caret key. If you're going to use the E key, this is going to be 7.34 E45, no parentheses is necessary, divided by 6.02 E23. Again, no parentheses is necessary. So clear your calculator. If you're using the E key, 7.34 E45 divided by 6.02 E23 equals. If you're not using the E key, then clear your calculator, open parentheses, 7.34 times 10 caret key 45 close parentheses divided by open parentheses 6.02 times 10 caret key 23 close parentheses, press the equal sign, and let's see what we should get. 1.2, and if you read all the way across, it says to say times 10, and there should be a 22. Again, there's our number, there's our unit, and what it belongs to. If I was writing it with the E, it would be 1.2 E22 molecules. Now don't shortcut that. Molecules is just molecules. Oh, I'm sorry. We're looking at moles. Dr. Hudson. Been doing this a bit. Moles. Sorry. Moles. H2O. You can shortcut that. If I wanted it to the nearest whole, it would be 1 times 10, 22 to the 22 mole of H2O. Or it would be 1 E22 mole of H2O. Okay, now let me make sure I'm clarifying this for you. There is no shortcut for molecules. You just have to write molecules. You can write mole, but don't ever get moles and molecules mixed up, please. Because mole, M-O-L-E, is not a molecule. They are two different things. So your units are either moles, or you can use a little shortcut for mole, which is M-O-L. But there is no shortcut for molecule. You just write molecule out. Don't get the two of those confused, because then you might have the number correct, but you might have the unit written wrong, and the whole thing's going to be wrong. Molecule is a whole lot different than a mole. Okay? Just make sure we're clear on that. All right, given 26 liters of water, find the grams. Oh, this is going to be a fun one. So we know we have moles. I'm putting mole here. And I know I can go from moles to mass, which is in grams. And I know I can go from moles to volume, which is in liter. I know to go from moles to mass, I have to use grams per mole, which is on your red, white, and blue periodic table. And I know to go from moles to volume, I use 22.4 liters. This says that I start out with a volume, and I want to go from volume to a mass. Well, I can't just hop from volume to mass. I have to go to moles first to get there. I think I'll put this in a different color so you can see it a little bit clearer. I have to go to moles first in order to get from one to the other. So, to go from volume to moles, I'm not going from moles to volume, so I'm not multiplying. I'm going to have to divide this by 22.4. And to go from moles to mass, well, I can multiply by the molar mass. So I'm going to take my 26 liters, I'm going to divide that by 22.4 liters, and then I'm going to take that information and I'm going to multiply it by the molar mass of water to get the grams of water. If you need to write this down so you can see the path that we're going to take, go ahead and do so. Otherwise, you ready? Let's go. Okay, let's see the setup. 26 liters. Like I said, we have to divide it by 22.4, and then we have to multiply it by 18. Well, sometimes the way they have it can look kind of confusing, so let me write that out for you. You're going to take your 26. Remember, we said we're going to divide that by 22.4, and then we're going to take that number and we're going to multiply it by 18, and that will give us our answer. So, clear your calculator. There are two ways you can do this. We are going to take 26 divided by 22.4 in parentheses, and then we're going to multiply it by 18, okay? All right, so clear your calculator. Open parentheses. 26 divided by 22.4, close parentheses, times 18 equals. Now, if you've done it that way, hold it right there, and we'll check in a second. If you're going to do it another way, the other way you can do is you can multiply all the ones at the top here divided by all the ones at the bottom, which is going to be in parentheses 26 times 18, and the whole thing is divided by 22.4. So if you're going to do it this way, clear your calculator, open parentheses, 26 times 18, close parentheses, because you're telling your calculator that everything at the top is going to be multiplied together as one thing, divided by 22 times 0.4, equals. Okay, we ready to check ourselves? Once the liters cancel out and we're left with just grams, we have our setup of 26 times 1 times 18 divided by 22.4. You should get 20.9 grams of H2O. My number is given, my units and where they go to is given. Okay? If I wanted this to the nearest whole number, it would be 21 grams of H2O. And I can put G because G is shortcut for grams, or I could write grams out. Okay. All right, I have shown you all those ways. Whichever way works for you, go ahead and take it. So here we have 3 practice problems. Pause the video as we do each one, and then press play and check yourself, okay? So let's look at the first one. Given 12 grams of oxygen, find the moles. Pause the video, and then come back when you're ready to check and see if you have it right. So here I have grams to moles. So my mole is here, and I go to and come from the mass, which is in grams. I'm going from grams to moles, so I'm not going to multiply. I'm going to divide to get from grams to moles. And I'm going to have to do that with the molar mass. So I look at my red, white, and blue periodic table. It tells me that the mass of O2 for 2 oxygens is 2 times 16. So I need to divide 12 grams divided by the mass of O2, which is 2 times 16. That's the molar mass of a molecule of O2. And that's grams per mole. So my grams cancel out. And that's just me doing the units. So use your calculator. put in 12 divided by, open parentheses, 2 times 16, close parentheses, press the equal sign, and my answer should be a 0.75 moles of O2. And I'm going to pause here for a second. This is to the nearest hundredth. If I wanted it to the nearest, nearest thousandth. If I wanted it to the nearest hundredth, it would be 0.3, and that's not going to be a 7 because there's a 5 beside it. It would be 8 moles of O2. If I wanted it to the nearest tenth, it would be 0.4 moles of O2. Could I put that to the nearest whole number? No, because the nearest whole number would just look like there's 0, and that's not true. So I would not put that to the nearest whole number. That would not even be feasible. All right, look at it carefully. Okay, let's go on to the next one. Given 6.5 moles of ammonia, find the liters. Again, pause the video and then press play to check and see if you got it correct. So this time I'm going from moles. Let me make this a little thinner. There we go. Moles to liter, which is volume. So I'm dealing with 22.4 liters. And I'm going from moles, so I'm going to multiply. So I'm going to take 6.5, which is my moles, and I'm going to multiply that by 22.4 to get an equal sign. So clear your calculator. 6.5 times 22.4, and the answer to that is going to be 145.6 liters of ammonia. That is to the nearest tenth. The nearest whole number is going to be 146 liters of NH3. Okay? All right. Let's do the last one. 3.5 liters of H2SO4. Find the grams. So this time, I've got my mole. I've got my volume. I'm dealing with 22.4 liters. And I've got moles to my mass. And my mass is in grams per mole. No number because that depends on the compound or the substance that I'm dealing with. And I'm going from liters to grams. So I'm starting over here where liters is. And in order to get from liters to grams, I have to, of course, go through moles. But since I'm not going from moles to liter, I'm going to divide. So I'm not going to multiply. But I am going from moles to mass, so I am going to have to multiply. Okay, so I have 3.5 liters, and I'm going to have to divide that by 22.4 per mole. And then I'm going to multiply the whole thing by the mass of H2SO4. Well, what's the mass of H2SO4? Well, let's see. I have one hydrogen, two hydrogens, that has a molar mass of 1. I have one sulfur, which has a molar mass of 32 grams per mole. And I have 4 oxygens with a molar mass of 16 grams per mole. So I'm going to have to add those all together. So I'm going to clear my calculator, open parentheses, 2 times 1, just so we can follow protocol, plus 32, plus, open parentheses, 4 times 16, close parentheses, and I'm getting a 98 grams per mole. Okay, so then I'm going to multiply this by 98 to get my grams per mole. So now I got to look at the whole thing. So I'm going to clear the calculator. I'm going to open my parentheses. 3.5 divided by 22.4, because that says that's what I got to do. And then I have to close parentheses, multiply the whole thing by 98, and let's see what the answer for that is. You should have gotten 15.3 grams of H2SO4. This is to the nearest tenth. If I wanted it to the nearest whole number, it would be 15 grams of H2SO4. Okay? All right, so if you got that correct, you are doing fantastic. If you had difficulty with it or you still have clarifying questions that have not been answered, then I strongly recommend that you address that with your instructor. Okay? All right. So let's look at what happens when it's written as a word problem. Yes, welcome to the world of word problems. In a chemical reaction, the number used to balance the equation is equal to the number of moles of that atom or molecule. So we already know that because remember we balanced our chemical equations, and remember we had to put coefficients because we could not change the formula for that. So I can give you a chemical equation, and then I can ask you, how many moles of water do you have? Well, the coefficient tells me that there are 2 molecules of water. There are 2 molecules of the hydrogen atom. There is 1 molecule of oxygen, right? There are also considered to be 2 moles of water. So here we are learning that the number used to balance the equation, which in this case was a 2, is also equal to the number of moles. So moles and molecules in the balance equation, the coefficient of a balanced equation is equal to the number of molecules, but it is now also equal to the number of moles. That is your new information. You're used to balancing equation and we tell you how many molecules there are. Now we're telling you that that coefficient in a balanced equation is now also equal to the number of moles in that balanced equation. Make sure you put a star beside it or something, because that is very important information, especially as we start your third quarter and we go into stoichiometry, which is the conclusion, I'd say, of mole conversion. Okay? And of course, practice makes perfect. So, look at the equation. How many moles of water are there? Well, where's the formula for water? Here's your formula for water. So how many moles of water are there? Hopefully, you're saying that there are 3 moles of water. Look at the other equation. How many moles of oxygen are there? Where is your oxygen? Remember, oxygen is not just O, because when we're talking about oxygen, we're talking about, if we're talking about molecules or moles of oxygen, we'd say atom or something. If it's just the O, we're talking about oxygen, the molecule. That is going to be right here, the O2. So how many moles are there? Well, just look at the coefficient. There's going to be 7 moles of oxygen. And then finally, how many moles of copper 2 nitrate are there? You have to know your formulas. I think I told you this before. You've got to know those formulas. Which one of these is copper 2 nitrate? Hopefully, you've chosen this one. Notice that there is no coefficient, so there is only 1 mole of copper 2 nitrate. You have to know the names of your compounds. You have to know the formulas of your compounds. Again, I cannot impress upon this more than anything. You've got to know this. I can't impress this enough. Please make sure you know this. Please make sure you know your polyatomic ions so that you can answer these questions. Okay? You don't have time to try and figure this out, especially when you're taking an assessment. Okay, look at this one. Which of the following gas samples have the largest number of representative particles at STP, or standard temperature and pressure? I am going to advise you pause this, perform the necessary applications, because you want to know the largest number of particles given these different liters of a solution. So pause this, see if you can calculate it, come back and check. Okay, so we are going from liters to particles. We know that moles is in the center. So moles to volume. And we know if we're going from moles to volume, we're using 22.4 liters. And we also know we're dealing with particles. So we know we're dealing with Avogadro's number of 6.02 E23. These are in liters. So I'm going from volume to moles. To go from volume to moles, I'm not multiplying, I'm not going from moles to volume, so I'm going to have to divide this by 22.4. But I am going from moles to particles, so I'm going to have to multiply this by 6.02 E23. Hopefully that's what you did. So your answer is to take 17 liters divided by 22.4, and then that answer is multiplied by 6.02 E23, and you get 4.568 times 10 to the 23 particles of chlorine. If I take the 5 liters of fluorine, I take 5 liters divided by 22.4, and that answer I multiply by 6.02 E23. Ooh, that 23 means to be a little bit higher. Don't know how that happened. And that is going to give you 1.344 times 10 to the 23rd power. And then finally, I'm going to take the 29 liters of neon divided by 22.4 and take that answer, multiply it by 6.02 E23, which is what we mapped out we were going to do, and that is going to give you 7.79 times, or E to the 23 particles. So which has the largest number of particles? You have 4.568 E to the 23, 1.344 E to the 23, and 7.79 E to the 23. Which one is the largest of those three? You should have chosen the 29 liters of neon. If you got that correct, you are doing just fine. If you still have some lingering questions and answers, not quite sure how we got that, those are things that you need to make sure you address with your instructor. Okay, I will see you on the 3rd installment of this lecture series. Have a great day.